Hey guys, welcome to our second tutorial. This time we're not going to discuss linear mortgages but annuity mortgages. So linear mortgages had it as a prime feature that, let's say, the repayment on the mortgage is constant over the complete maturity. So let's say within 30 years, each month we're going to repay the same amount to redeem the mortgage. Annuity mortgages are somewhat different. They have as a prime feature that, let's say, the total payment, so of interest and repayment of the mortgages as a total, as a sum, they are constant during the whole mortgage. So each month we're going to pay the same amount as a composition of, let's say, interest and redeeming the mortgage. So let's do this example. For instance, we again take a mortgage of 300,000 euros. And the annual percentage rate, like in the last example, is 5%. And the maturity, again, like we said, mortgages are usually standardized at 30 years. So we take the 30 years as a maturity. And then, first we start calculating what is this constant payment, this sum of interest and repayment. And we learned a formula for this. This is the same formula we use as we start calculating a constant thing of cash flow and we want to discount those. So actually what we're going to do, those annuity, the unknown, is nothing but this constant string of annuities discounted over the 30 years, or let's say over the 360 months. Because usually we repay mortgages in monthly, so let's say that's 360 months, 30 times 12. So how are we going to do this? The annuity is nothing but this number here. And let's fix this. The total mortgage divided by, and then let's see if you still know it. 1 minus, and then 1 plus the annual percentage rate, but this is an annual percentage rate. So we divide this by 12 to the power minus the number of payments or periods, and in this case this is a monthly period, so let's say minus this number, but this is yearly, so times 12, times 12, and then we divide that number by the monthly payment, monthly interest rate. So this is this one divided by 12 again. And let's say, for Excel's sake, we put some extra brackets behind these, and then I made a mistake. Let me check what is wrong. And this one should go. And now we have, I'm sorry, yeah, this is somewhat tricky. Sometimes with Excel you have to look at those brackets. But this is, let's say, our answer. And this is the annuity we're going to pay. So a little more than 1,600 euros we have to pay each month to repay the mortgage, so the 300,000 plus interest. So if we drop this down, because nothing is changing here, we're going to repay each month this amount of money, 1,600 euros, a little bit more than 1,600 euros. So that's it. So let's say 1,610 euros and 46 cents. Okay, the interest rate, so this number, this 1,600, a little more than 1,600 euros, what is the composition of interest and repayment in this? Now that's not that hard. First of all, what is the interest payment we have to make within this first month? So that's 5%. Fix that. Times the 300,000. Only now this is the annual percentage rate is yearly, so again we should divide this by 12. That is the interest rate we're going to pay. So what is the redeeming as a logical consequence of this? This is nothing but the difference between the. This is what we in total pay. This is the interest rate we have to pay for the first month. So this is the redeeming 360 euros and 46 cents. So what is the outstanding debt we have with the bank after the first month? That is, we had 300,000 in the beginning when we bought the house, minus the 360 we redeem on this mortgage. For the second one, for the second month I should say, what happens? Again, like we know from linear mortgages, it's nothing but we should pay again the 5% times, now no, not times the 300,000 in this time, but let's say times the outstanding amount of debt we have with the bank, times this. Corrected because the annual percentage rate is annual and we pay monthly. So this is the interest rate we pay. Oh, it's not times 12 but divided by 12. So we pay a little less in interest, let's say 1,248 euros and 50 cents. What is the repayment? This is nothing but the difference between the annuity, this fixed amount we pay each month that has over time a different composition within interest and repayment, minus the interest we pay, and we start redeeming a little bit more, not 360 euros but 361 euros. What is the total amount in debt we have? Is nothing but this was the debt after 1 month, and we in the second month we redeemed a little bit again, let's say 361 euros. So this is it. And we're not going to do this like with the annuity mortgages 360 times. No, we let Excel do this. So we drop this thing down for the 360 months. And what do we see? First of all, it should be noted that each month we pay the same amount as a total. Okay, perfect. After that you would say, in the beginning we pay a lot of interest and we redeem, let's say, not that much. We start with 360 euros. But during the course of time, what do we see? The interest rate payments become smaller, and let's say the redeeming on the principal, let's say on the mortgage we took out starts increasing. So this is what happens. And for instance, if we look at what we in totally pay on this mortgage, now let's take these sums. Let's say this is what we pay, almost 580,000 euros on the 300,000 we lent in the beginning. How much do we pay in interest? So that's 280,000. How much do we redeem? And this number should be fixed. Exactly, the 300,000 we loaned. So you see, if we pay 1,610 euros and 46 cents, we completely redeem the mortgage. The 300,000 we lent, we completely repay, and we pay almost 280,000 euros in interest. So this is how an annuity mortgage works. And The new thing about is that we needed this special formula. The formula we used already with other present value calculations, but this is what we needed. That we said, okay, we now get 300,000, and in the future we'll be paying 360 times a certain amount of money, the annuity. And the whole idea was that, let's say, future money is worth less in the present because of, let's say, the time preference of money, interest rate risk. These things we discussed. So hopefully this is clear. I also created a graph so that we can see, let's say, now the total payment, what we pay each month, is the same. And we see these, by the way, are not linear functions. That the interest rate we pay in the beginning is, let's say, 1,250, and it decreases, while, let's say, the redeeming starts increasing. So this is exponential. In that sense, we start redeeming 360 euros and 46 cents, but this increases over time. So this is an annuity mortgage. Thank you for your time.